agriculture economics at ICR Atari Zone 8, Pune from 2021. Earlier to this, he served as a scientist at IASRI, New Delhi, for 5 years. He has completed a MSc Agriculture Economics from US Bangalore and worked in the Nationalized Bank for 1 year. Then resigned that job and completed a PhD in agriculture economics from IARI New Delhi, and joined ARS in 2017. He has experience in technology dissemination through the involvement in the programs like Farmer First, attracting and retaining youths in the agriculture, cluster frontline demonstrations on pulses, Damu under the GKMS scheme, promotion of the FPOs, pulses, seed hub, outscaling of the natural farming projects through the KVKs. He is also involved in monitoring frontline extension work, organizing various HRD activities for 82 KVKs of Maharashtra, Gujarat, Goa of ICR Atari Zone 8 Pune. Uh, he has been associated with the Network Research Project of Agriculture Extension Division of ICR New Delhi on Nutri-Smart Villages, development of entrepreneurship and impact assessment of pulses. He is also recipient of various fellowships such as IRI, IARI Fellowship for the Doctorate of Philosophy in Agriculture Economics at the Division of Agriculture Economics, IARI New Delhi. He is the recipient of the fellowship UGC JRF Fellowship Award in the subject of economics. He has published 60 publications to his credit, including research and review papers, book chapters, training manuals, technical bulletins, popular articles, e-publications, and other. Uh, his research interests include, but are not limited to the impact of public expenditure on the research and development in Indian agriculture, identifying determinants of the total factor productivity in the major crops of India, developing district level optimum crop planning strategies to increase the productivity. He has taught various courses to the UG students at Niazam Baramati, to the PG and PhD student scholars at the IARI New Delhi on various subjects like the fundamentals of agriculture economics, agriculture development and policy analysis, optimization of the techniques, demography, and high-tech fruit production. Today, he is delivering the lecture on the topic regression analysis and distribution lag model. Sir, I welcome you, and now floor is yours, sir. Please.
Thank you, sir, for the nice introduction. A very good morning to all of you. Today we are going to discuss about the topic regression analysis and distributed lag models. Actually, when I gone through the topics covered by different experts, I found that the topics on analytical methods was missing. Therefore, I thought of changing my topic from agriculture development programs of India to this topic, the regression analysis and the distributed lag models. In this lecture, first we will see the theoretical aspects of both the models, and then we will discuss the models with examples. Okay. First, we will consider regression analysis. As you all aware, regression analysis measures the nature and extent of the relationship between two or more variables, thus enables us to make predictions. In fact, regression is the measure of average relationship between the two or more variables. Now we will see what are the utility of this regression analysis. Firstly, it helps in establishing a function relationship between two or more variables. Secondly, regression analysis serves as a tool for solving many problems of economic and business research. And the important use of this technique is for prediction or estimation of the future production, price, sales, income, profits, etc., which are of great importance to the policymakers. Also, this can be used in sociological studies as well as to estimate the various factors such as birth rate, yield rate, etc. Okay. Once when we are discussing about the regression, it is important to know the basic difference between the correlation and the regression. That's why I have put 2 slides for this. Basic first related to degree and nature of relationship. Basically, correlation is a measure of degree of relationship between the x and y variable, whereas a regression studies the nature of the relationship between the variables, so that one may be able to predict the value of one variable on the basis of another variable. And next is cause and effect relationship. This is one of the major difference between a regression and correlation. Correlation does not always assumes cause and effect relationship between the variables, whereas regression clearly expresses the cause and effect relationship between two variables. Take for example, expenditure of an individual is a function of his income. Okay, if income of an individual increases, then only he or she will be able to spend more. Thus, here the increase in income is the cause, and increase in expenditure is the effect. That means increase in income, it is the increase in income is the independent variable, whereas increase in expenditure is the dependent variable. Similarly, related to prediction, correlation does not help in making predictions, whereas regression enables us to make predictions using regression line. Then you might be knowing very well that symmetric correlation coefficients are symmetrical. That is, R, the correlation coefficient is denoted by R. Rxy will be equal to the Ryx, whereas regression coefficients are not symmetrical. Bxy, the regression coefficients are indicated by the letter B. Bxy will not be equal to the Byx. Then origin and scale. Correlation is independent of the change of origin and scale, whereas regression coefficient is independent of change of origin but not of scale. Here, change of origin means if we add or subtract a value from the variables, then also we will get the same result in case of both correlation and regression. When we divide or multiply that value with some particular number, then we will get the same value in case of a correlation. That's why it is independent of change of scale also, but it is not the case. It is not in the case of regression coefficient. Okay. Now we will see the types of regression models. First one is a simple linear regression model. And the simple linear regression model is usually denoted as yi is equal to alpha plus beta 1 xi plus ei. Here yi is the independent variable, dependent variable is xi, and alpha is the intercept or constant, and beta 1 is the coefficient of regression, and here ei is the error term. Okay. Now these are few examples where we can use the simple regression analysis. For example, to study the influence of rainfall on the crop yield. Also to examine the influence of advertisement, that is expenditure on advertisement on sales of the product. There also we can use a simple regression analysis. Then to study the influence of income on consumption expenditure. Okay, these are some of the examples. In many cases, we can use this regression analysis. Next, this is about simple regression analysis. Then coming to the multiple linear regression model. Actually, this multiple linear regression model is a regression model that involves more than one independent variable. That is, it involves more than one x variables. The multiple linear regression model is used to study the relationship between a dependent variable and one or more independent variables. And it is denoted as given in this formula, y is equal to beta naught plus beta 1 x1 plus beta 2 x2 plus up to beta p xp plus e. Here y is the dependent variable and x1, x2, up to xp are the independent variables, and beta naught is the intercept, and beta 1, beta 2, beta up to beta p are the partial regression coefficients. Okay. As we have seen in the previous slide, the beta naught is the intercept of the regression model, and here beta 1 indicates the expected change in y per unit change in x1 when x2, x3, x4 up to xp are held constant. Similarly, beta 2 beta 2 here. Beta 2 measures the expected change in y per unit change in x2 when x1, x1, x3, x4 up to xp are held constant. For this reason, the parameters beta I for all, beta 1, beta 2 up to beta p are often called as a partial regression coefficients. Okay. In simple term, multiple regression analysis, we have one y variable and more than one x variables. Here, we have few examples for the same. Like the study of effect of rainfall and irrigation on the crop yield can be analyzed using multiple regression analysis. Here, rainfall and irrigation are the independent variables, and the crop yield is the dependent variable. And in the second example, we can see that multiple regression analysis can be used to study the influence of advertisement expenditure and income of the people on sales of the produce. Here, advertisement expenditure and income of the people are the independent variables, and sales of the product is the dependent variable. Okay, now we will discuss three examples in this case. In this case of regression, in the first example, we will see how to form a regression equation, and also we will discuss about the coefficient of regression. In the second example, we will discuss about the procedure, step-by-step procedure of doing regression analysis. And in the third example, we will use a real data set and try to solve the problem using a regression analysis. So this is the first one. Here we have a data of advertisement expenditure and sales, and these are in rupees crores. Okay, here we have a data for 6 years. Okay, how to proceed in this case? First consider one case, that is y on x. Here y is sales and x is advertisement expenditure. Sales depends on advertisement expenditure. If this is the case, then we have y minus y bar is equal to byx into x minus x bar. Here byx is the coefficient of regression equation of y on x. Similarly, x on y, this is for y on x, and this is when we calculate for a fifth year. We are calculating here y value. For this, we need to calculate byx. Then similarly, for the when we calculate for the sixth year, the value of x, we need to calculate the coefficient of regression equation of x on y, that is bxy. Okay, this is the scenario. And now we will see the coefficient, actual formula for the regression coefficients. Okay, here in this slide, we will see the formula for regression coefficients. To get the value of regression coefficients, we need to compute and substitute the values of this sigma xy, sigma x, sigma y square, sigma y whole square, and also sigma x whole square to get the value of regression coefficients. So we will see how to do that one. Okay, here we have two variables. Here in this example, we will see that stepwise procedure for doing a regression analysis manually. Here we have two variables x and y and have 5 data points. We need to calculate xy, x square, y square. By this, we will be able to get sigma xy, sigma x square, and sigma y square. Now the question is that what likely to be the value of x if y is equal to 10? Suppose here we don't know the value of okay, here we don't know the value of x when y is 10. So for that, we need to estimate regression equation. Then we have to substitute the values. We will see how to proceed in that. The first question is what likely to be the value of x if y is 10, and what likely to be the value of y if x is 10. That is x on y and y on x. Both we need to calculate. First, we will see x on y on x. That is here the regression coefficient is given by byx is equal to n sigma xy minus sigma x sigma y whole divided by n sigma x square minus sigma x whole square. Okay. From the previous tables, we got the value of the sigma xy, sigma x square, sigma y square, and all. So now we will substitute these values. Here, n is 5, it is the number of data points. N is 5 into sigma xy, it is 184. Then minus sigma x, it is 24. Then sigma y is 40, whole divided by n is 5 into sigma x square. This is x square, and its total is 142. 5 into 142 minus sigma x whole square. Here sigma x is 24 whole square. So after simplifying it, we will get the value of minus 0.298 as the regression coefficient byx. And we know y bar is the mean value of y, and x bar is the mean value of x. Y bar is given by sigma y by n, that is 40. 40 by 5 is equal to 8, and x bar is 24. Sigma x 24 divided by n, that is 5, it is 4.8. Okay, here we got the value of regression coefficient byx. Now we will calculate the value of bxy. And this is the formula. Similarly, we will substitute the values, and we will arrive at this value, that is bxy is equal to minus 0.133. Okay, now that's clear. Now we will formulate regression equations. First, we will consider y on x. We have y minus y bar is equal to byx into x minus x bar. Substitute the value of x bar, byx, and x and y bar in this equation. After simplifying, we will arrive at this regression equation, that is y is equal to minus 0.298x plus 9.4304. Okay, here as we know, it is the regression coefficient value minus 0.298 in case of y on x. Similarly, in case of x on y, we have this equation, x minus x bar is equal to bxy into y minus y bar. After substituting the values of x bar, y bar, and bxy, we will arrive at this regression equation, that is x is equal to minus 0.133y plus 5.864. Right? Now we got both the regression equations, and now we will try to answer the actual questions. Just a reminder, what is the first question is that what likely to be the value of x if y is equal to 10. Okay, now we have regression coefficients value, so and we have regression equation. So just substituting by substituting, we will arrive at the values. So what is the value of x if y is 10? So we have the equation, just substitute the value of y here, so it comes to x is equal to 4.534. Similarly, what likely to be the value of the next question was what likely to be the value of y if x is equal to 10? That is, y depends on x. Here we have regression equation, y is equal to minus 0.298x plus 9.4304. So by substituting the value of x in this equation, we will arrive at this value, that is y is equal to 12.4104. This is the stepwise procedure to do regression analysis. Of course, we can easily get these results in various softwares, and of course in Excel also, but we need to know the basics of those. That's why I try to explain in this example. Now for better understanding, I would like to consider one real data example. First, let me share the Excel. So is it visible?
Yes, sir. Yes.
Okay. Thank you. Now consider this data given in this table, which related to Indian economy for the period 1951 to 2007. Here is the data. And here X variable, X is PFCE, that is aggregate private final consumption expenditure. In simple terms, you can keep it as consumption expenditure, aggregate consumption expenditure. Then here X is GDP, gross domestic product, which is a measure of aggregate income. Okay, it is the consumption expenditure and it is the measure of aggregate income, and both are measured in rupees crores. Okay, now we will see how to run regression in Excel. First, go to the data. From data, we need to select here data analysis. Here we need to select regression. Then click on OK. Then now select input Y range. From here I am selecting from PFCE. This is the input Y range. Then I will select the input X range. Okay, since I have selected the label cells also, that's why I am clicking on this labels box. And now we will select the output range. I mean, where we would like to get the results. Here I will select this E2 cell. Okay, now it's okay. We'll select here E2. Yes. Now we got this result. Here you can see that what are the points we need to see in case of interpreting the regression results? Lecture. One second, just a minute. Just a minute. Okay, lecture. Sorry for the disturbance. Okay, this is the result we got from the regression analysis, and then how to interpret the results. Here we need to see this one, that is significance f value. It is less than 0.05, so we can say that the model is well fitted and it's significant. Then we can see the value of R square. Actually, this value indicates that in this example, we can say that 65% of the variation in Y is explained by the X variables. Okay, only 65% of the variable is explained by this X variable. That is about R square. And here the important thing is here these things: intercept and the beta coefficient, that is regression coefficient. Here the intercept term is 240,417.6092. This is the intercept term, that is alpha, and beta, that is beta naught, and beta 1 is 0.4429. Okay, 0.4429. Now we will go back to our slide. Yeah, this is the result. This is the result. Here, with that analysis, we can write a regression equation like this: YT is equal to 240,417.6. It is the intercept term we got there, plus 0.4429 XT. This is the regression coefficient we got there. So how to interpret this? An increase in real income of 100 rupees lead to an average of about 44 in real consumption expenditure. In other words, for 1 rupees increase in the real income, it leads to an average an increase of about 0.44 rupees in consumption expenditure. This is how we need to interpret the regression analysis. I mean, this is about this concept, that is regression analysis. Now we will go to the distributed lag model. It is the advancement in regression analysis only. And this is the distributed lag models. But before going to the main topic, that is the distributed lag models, first we will see some basic concepts behind this. Basically, in time series analysis, there are two types of models. First is static models and dynamic models. First, we will see what is a static model. A time series model where only contemporaneous explanatory variables affect the dependent variables. It means the effect is assumed to operate within the same period. For example, the changes in x variable, influences the y variable in the same period. These are called as static models. For example, yield is a function of rainfall. This is just an example. This yield is a function of rainfall. This year's rainfall pattern affects the yield of this year only, right? This year's rainfall pattern affects the yield of this year only, not the next year's crop yield. This is what static models says. Whereas dynamic models, it means a time series model where the lagged value of independent variable affect the present value of dependent variable. I will explain this with an example. Investment made by the government or the ICR on research and development in agriculture will have its influence on yield through the development of new varieties or technologies after a period of time. We will able to get the result of higher yield or advances in efficiency in the process only after a period of time. So there is a lag in this process. These dynamic models, they are able to capture that effect of lag. This is about the dynamic models. Now coming to the actual concept, that is distributed lag models and auto-regressive model. First, distributed lag model. It refers to the regression model, which includes not only the current, but also the lagged value of explanatory variable. That is, this model can be given as yt is equal to alpha plus beta naught xt plus beta 1 xt minus 1 plus beta 2 xt minus 2 plus ut. Here we can see the lagged value of x, that is xt minus 1 and xt minus 2 among the explanatory variables. These types of models are known as distributed lag models, whereas auto-regressive model, it is exactly opposite to the distributed lag models. Here, the regression model includes one or more lagged value of the dependent variable, that is y variable only, among the explanatory variable. This is the model yt is equal to alpha plus beta xt plus gamma yt minus 1 plus ut. Here we can see that the lagged value of y, that is yt minus 1, among the explanatory variables. So these type of models are called as auto-regressive models. Okay. Now the basic questions are, what is the role of lags in economics, or particularly or in general in agriculture? What are the reasons for lags? Is there any theoretical justification for the commonly used lagged models? And what are some statistical problems involved in estimating such models? Actually, we will try to answer a few of these questions in the coming slides. First, we will see what is a lag. Hello?
Yes, sir.
Okay. Okay. First, we will see what are the lags. In simple terms, it is the lapse of time. Actually, in general, it takes time for the y variable to respond for a change in x variable. Okay. Now consider the finite distributed lag model. It is given as yt is equal to alpha plus beta naught xt plus beta 1 xt minus 1 plus beta 2 xt minus 2 up to beta k xt minus k plus ut. Here beta naught is here beta naught is known as the short run multiplier. It is also known as impact multiplier. Beta naught plus beta 1 plus beta 2. These are together known as interim or intermediate multipliers. And beta naught plus beta 1 plus beta 2 up to beta k, which is given by beta, it is known as the long run or distributed lag multipliers. We will see the explanation of these multipliers in the coming slides. Now we will see what is the need for DLM. As I said in the previous slide, in general, the dependence of y variable on another variable is rarely instantaneous. Very often, y responds to x with a lapse of time. Therefore, we need models like distributed lag models to capture that effect of lag. Here we will see few examples where time plays lag plays an important role, and here we can use DLM. First, as we know, there is a lag between R&D expenditure and productivity. Being in the ICR system, we know that if government or ICR spends some lakhs of crore rupees on agricultural R&D, take for example for developing a new variety or a technology, it will take 4 to 5 years for its development. After that, it will take 1 to 2 years for its acceptance by farmers. I request others to please mute yourself.
Mahesh sir, please mute yourself. Mahesh sir, please mute yourself, sir.
Others admin can mute. Okay, I will continue.
ಸರ್ ಎಲ್ಲಿದು ಆಗಲ್ಲ ರಿಜಿಸ್ಟ್ರೇಷನ್ ವಿಂಡೋ ಕ್ಲೋಸ್ ಮಾಡ್ಯಾರ ಬರೀ ಲಾಗಿನ್ ಅಷ್ಟೇ ಅದ ಅಂದ್ರೆ ಯಾರು ರಿಜಿಸ್ಟ್ರೇಷನ್ ಮಾಡಲ್ಲ
I request admin to please mute them.
ಮತ್ತೆ ಕರೀತಾರ ಇದು ಇಲ್ಲ ಕರೀತಾರೆ ಸರ್ ಚೆನ್ನೈ
Okay, thank you. As I was explaining about the lag between R&D expenditure and productivity, it will take 4 to 5 years for the development of a new variety or technology, and after that it will take 1 to 2 years for acceptance by the farmers in a larger scale, which leads to larger adoption. Then only we can see the results of higher yield. So after it will take around 6 to 7 years for a 6 to 7 years of time lag of the initial investment in agricultural R&D and the higher productivity gain. So in this case also we can use the DLM models. Similarly, we can study how the current money supply affects or influences the future prices, that is inflation. Then the consumption function, that is how increase in income influences expenditure on consumption of an individual. This consumption function example I will explain in detail in the coming slide. Now, just for the better understanding, I would like to explain this concept with this particular example. Suppose a person receives a salary increase of $1,000 in an annual pay. Then what will be the effect of this increase in income on person's annual consumption expenditure? Okay. Generally, what happens after receiving such a gain in income, people usually do not rush to spend all the increased income immediately. Thus, our recipient may decide to increase his consumption expenditure by $400 in the first year, then by another $300 in the second year. It means in the first year he will increase by $400. In the second year, 400 plus 300. That is $700 in the second year. Then in the third year, by another $200. That is 400 plus 300 plus 200. So totally $900 in the third year. So by the end of third year, the person's annual consumption expenditure will be increased by $900. And we can write this consumption function as YT is equal to constant less 0.4 xt plus 0.3 xt minus 1 plus 0.2 xt minus 2 plus ut. Here YT is the consumption expenditure and X is the income. Okay. In general, we can write this consumption function as given in the first equation. YT is equal to alpha plus beta naught xt plus beta 1 xt minus 1 plus beta 2 xt minus 2 up to beta k xt minus k plus ut. And this is second equation. This is our derived equation. And Here we can see that the short-run multiplier, as we have seen in the previous slide, short-run multiplier is beta naught in this general equation, and in our case it is 0.4. And interim multiplier is beta naught plus beta 1, that is 0.4 plus 0.3, it is 0.7. And then then the sum of all the beta coefficients, that is beta naught plus beta 1 plus beta 2, which is indicated by beta k or beta, sorry, which is indicated by beta, it is known as long run distributed lag multiplier. Okay, this is the long run distributed lag multiplier. Then this beta I star, which is given by beta I by sigma beta I, or beta I by beta, it is known as standardized beta I. Beta I star is known as the standardized beta I. Actually, partial sums of these standardized beta i's gives the proportion of long run impact felt by certain time period. We will see in our example. We know short run multiplier is 0.4, interim is 0.7, long run multiplier is 0.9. Okay, so here it indicates that for a $1 increase in income, the consumer will increase his consumption level by about 40 cents in the year of increase, by another 30 cents in the year of in the next year, and by yet another 20 cents in the third year. Okay, and this is what this multiplier indicates. Then the long run impact of an increase of $1 increase in income is thus 90 cents. Okay, from the previous slide, we know that beta I star is the standardized beta I, and it is given by this equation: beta I star is equal to beta I by sigma beta I, or beta I by beta. Okay, so in our case, we will calculate this standardized beta I for the for each year. For the first year, we will consider this one. For the first year, it is beta naught by sigma beta I. Beta naught is 0.4. The sigma beta I is, it is the sum of all. So beta naught plus beta 1 plus beta 2, it is 0.4 plus 0.3 plus 0.2, it is 0.9. So 0.4 by 0.9, it is a 0.44. Similarly, for the next year, it is beta 1 by sigma beta I. Beta 1 is 0.3 whole divided by 0.9. It comes to 0.33. Then finally, in the last year, it is beta 2 by sigma beta I. It is 0.2 by 0.9. It comes to 0.22. Okay. Then what it indicates? It indicates that 44% of the total impact of a unit change in X on Y is felt immediately. Then 77% means 44% plus 33%. 77% of the total impact of a unit change in X on Y is felt after 1 year. Then 100%, 44 plus 33 plus 22, around 100% of the total impact of the unit change in X on Y is felt by the end of second year. This is how the distributed lag model is estimated and the results are interpreted. Now we will see what are the reasons for lagged values. These are some major reasons, like psychological reasons, technological reasons, institutional reasons. Coming to the psychological reasons, as a result of force of habit, people do not change their consumption habits immediately following a price decrease or an income increase. Take for the example of winning lotteries. Those who become instant millionaires by winning lotteries may not change his or her lifestyle immediately, to which they are accustomed for a long time. Okay, they will take some time to change their lifestyle. Then technological reasons, imperfect knowledge also accounts for lags. Here we can take the example of iPhones. Even after the fall in the price of iPhone model, the people may hesitate to buy in the expectation that in the future the price of that model may further decline. So this is one of the technological reasons. Then about the institutional reasons, the contractual obligations may prevent firms from switching from one source of raw materials to another. That is because of contracts. And another reason is that Even if the price of some commodity, some luxury commodity declines, people may not be able to purchase that if they have deposited their money for in some financial institutions with some lock-in periods. So these are some institutional reasons. I mean, these are the few reasons for lagged values. And here we will see some other areas where these distributed lag models can be used. For example, to study the impact of advertising over several periods on current sales, by analyzing the impact of R&D in agriculture on TFP that we have discussed in the previous slides, impact of safety training on accidents, impact of marketing mix on market shares, impact of air pollution on mortality rate. I mean, these are some of the general examples where DLM can be used. Okay, thank you. Thank you for the patient listening. If you have any queries, you may please ask.